Did you ever play red light, green light when you were a kid? My grandkids play a game called What Time Is It, Mr. Fox? Whatever time Mr. Fox shouts out, that is how many steps you are allowed to take toward him. But watch out if he shouts lunchtime, for then Mr. Fox can run and try to catch you. Now, kids could probably play a game called What Time Is It, Mr. Moon? On April 2nd, on the spacepolicyonline.com website, Marcia Smith posted this headline: "What time is it on the moon? OSTP wants to know." The White House Office of Science and Technology Policy wants to establish standards for determining what time it is elsewhere in the solar system. The White House policy issued starts with the moon, directing NASA and other government agencies to develop a lunar timing standard it calls Coordinated Lunar Time, LTC, by the end of 2026 to support operations on and around the moon. They are also to work with the international community to make it the International Cislunar Standard. Cislunar, CISLUNAR, is the term to describe the area in space between the Earth and the moon. Previously, missions used the time zone of wherever the mission originated, Houston, Moscow, and so on. So you might be questioning the need to develop a lunar timing standard. OSTP Deputy Director for National Security Steve Welby explains the need for time standards as routine space operations move into cislunar space and beyond. Quote, "Time passes differently in different parts of space. For example, time appears to pass more slowly where gravity is stronger, like near celestial bodies. And as a result, the length of a second on Earth is different to an observer under different gravitational conditions, such as on the moon. A consistent definition of time among operators in space is critical to successful space situational awareness capabilities, navigation, and communications, all of which are foundational to enable interoperability across the United States government and with international partners." End quote. The moon's gravitational pull is weaker than Earth's, meaning that to an observer on Earth, a lunar clock would run faster than an Earth one. The estimate is that a lunar clock would gain about 56 microseconds over 24 hours. That might not seem like very much, but it can accumulate and you could still miss your bus. And standards are important. In case no one remembers, there was a big snafu when using both metric and imperial systems of measurements led to the Mars orbiter disaster in 1999. During the design phase, the propulsion engineers at Lockheed Martin in Colorado expressed force in pounds. However, it was standard practice to convert to metric units for space missions. Engineers at NASA's Jet Propulsion Lab assumed the conversion had been made. This navigation mishap pushed the spacecraft dangerously close to the planet's atmosphere, where it presumably burned and broke into pieces, killing the mission on a day when engineers had expected to celebrate the craft's entry into Mars orbit. Our current well-functioning Mars Reconnaissance Orbiter has just sent back some fabulous images. This amazing image was captured as Phoenix came in for its Mars landing on May 25, 2008. The high-rise camera on Mars Reconnaissance Orbiter pointed at Phoenix, which is seen here against the background of a 10-kilometer diameter crater called HEIMDALL. The dramatic view makes it appear that the Phoenix is falling into the crater, but in fact Phoenix was 20 kilometers closer to high-rise than HEIMDALL, and it landed nowhere near the crater. The photo was taken 20 seconds after Phoenix's parachute opened. This next image exposed diverse surface mineralogy around the Jezero Delta, a preserved river delta in Jezero crater, Mars, as imaged by the Mars Reconnaissance Orbiter. The colors denote the presence of different types of materials formed or altered by water. And this beauty. If you want to find ice on Mars, you may just have to scratch or impact the surface. Images like this one from the high-rise camera on NASA's Mars Reconnaissance Orbiter show impact craters on the Martian surface that have exposed water ice hiding beneath the regolith. The ice doesn't stick around forever, though. It will gradually sublimate from solid to gas because of Mars' low atmospheric pressure. So in future space travel to the moon and even onto Mars, it will be important to have standardization in all systems, or we will have to make sure to set our watches to match so that this doesn't happen.